every human has a lingering flame of curiosity, an inevitable call for exploration. This will to discover is what makes us more than just a survivalist species. It's the reason we were able to conquer the food chain, countries, continents, and now the terrestrial surface of Earth. But the longing for more can't be contained, and now we're looking at space. A vast world awaits us, bigger than anything we've ever explored. This is the story of our next step. This is the story of mankind. Mankind will continue to advance, and we will eventually start to colonize our neighboring planets. We will finally take the first steps to become an interplanetary species. But will that suffice? The main goal of any civilization is to become an interstellar species. The key to becoming one starts with exploration. This is Atlanta 1, a fictional spaceship that is the first of many in our search for exoplanets and potential strongholds in the void of space. While we continue to develop and change, this ship will finally reach the closest exoplanet to Earth. Welcome to Proxima b. Imagine being able to see not one, not two, but 3 suns in the Centauri sky. However, it is uncertain how habitable Proxima b could really be. Proxima Centauri is what's known as a flare star. It is many times more intense than the Sun, and periodically emits superflares that could potentially strip the atmosphere and any hypothetical oceans of Proxima b away, rendering it lifeless. As time goes on, many more satellites and expeditions will come, and soon the first humans. The day man steps on Proxima Centauri b will be the most important event to ever occur in the history of our species. The long-lasting dream of man has finally been realized, but at what cost?
In the coming millennium, mankind will become the interstellar species, venturing out into the unknown. One day, man will face the full force of space itself. Earth has protected man from many dangers of space with its powerful magnetic field and its atmosphere. There will be a need to create and innovate these incredible feats artificially on planets that can't. To create, we must first understand. Earth's magnetic field was generated by the movement of molten iron in Earth's core. To understand the forces that drive Earth's magnetic field, we must peel back the 4 layers of Earth. The crust, which is where we live, is about 19 miles deep on land and about 3 miles deep in the ocean floor. The mantle is a hot, viscous mix of molten rock about 1,800 miles or 2,900 kilometers thick. The outer core is approximately 1,400 miles thick and composed of molten iron and nickel. The inner core, which is a roughly 759-mile thick or 1,221 kilometer thick solid sphere of iron and nickel metals about as hot as the sun's surface. Nearly all of Earth's magnetic field originates in the fluid outer core. Like boiling water on a stove, convective forces which move heat from one place to another, usually through air or water, constantly churn the molten metals, which also swirl in the whirlpools driven by Earth's rotation. As this rolling mass of metal moves around, it generates electrical currents hundreds of miles wide and flowing at thousands of miles per hour as Earth rotates. This mechanism, which is responsible for maintaining Earth's magnetic field, is known as the geodynamo. But not all planets are capable of creating geodynamos. Solar flares from exoplanets' host star, or even supernovae and gamma-ray bursts can bake any planets without a significant magnetic field into a lifeless state. Without significant atmospheres, every tiny rock reaches the surface of a planet without burning up, which is why airless worlds are so full of craters. Like a magnetic field protects us from radiation, the atmosphere protects us from small asteroids. Clearly, the conditions that make a planet habitable are many, and it is likely that many of the worlds we come across on our journeys will be uninhabitable. To solve this problem, we will create asteroid defense systems, thicker, thinner atmospheres, and in some cases, maybe even artificial magnetic fields. But once we've expanded out into the stars and brought hundreds of star systems under our control, what could stop us now? What could possibly be more dangerous than the void of space? Beings born from it. One of the most widely accepted ways of categorizing extraterrestrial civilizations is called the Kardashev scale. It ranks civilizations into 3 categories based on their energy consumption. A Type 3 civilization, the most powerful type of civilization in the original model for the Kardashev scale, is also called the galactic civilization. A galactic civilization is capable of harnessing the power of an entire galaxy, able to encase billions of stars in Dyson spheres, using the rotational energy of the galaxy's central black hole to generate power and create, move, or destroy entire planetary systems at will. It is unlikely that a Type 3 civilization exists in our Milky Way, because if it did, we wouldn't be here. However, the fact that a civilization like this may even be able to exist is terrifying. To us, they'd be gods, capable of creating and destroying life with ease. When we go out in space, we won't just be going up against the forces of nature, we could be going up against the gods. As we develop and grow in the cosmos, other civilizations might notice us. If they're anything like us, they'll attack. Will they succeed? Probably. The first humans to be so far from their worlds in constant fear of death. To defend against evil, we must first learn from it. Our best chance is to theorize and imagine what an alien civilization with this much intelligence could do and could look like. This is Acropolis, a fictional civilization that is readying to end us all. What mind-boggling infrastructures could aliens like these build? There could be civilizations that could create and end universes in mere seconds, build Dyson spheres with the touch of a button. There's even a hypothetical megastructure that uses one central black hole and 8 stars in orbit around it to create the most stable and long-living planetary system in the universe. A system like this could host thousands of Earth-sized rocky planets in the habitable zone. Just imagine what we could do if we had a system like that. A system home to not billions, but hundreds of trillions of people. Or we could build the biggest museum of the galaxy has ever known, using each of the thousands of habitable planets to host a different ecosystem. But this is only one of the dozens of potential megastructures aliens or ourselves can build in the future. What would aliens like this look like? Aliens can appear in many shapes and forms: strong skeletons, huge brains, and body structures accustomed to the hostile environment of their worlds. While our future does seem bright from this perspective, there is always the lingering threat of extinction over our heads, and there may be nothing we can do to stop it.
Developing, growing, and protecting yourselves from the dangers of the universe won't help you much when you run out of time. We are prey, hunted by the universe itself. No matter how powerful we become, there is always something that could eclipse you. We won't die in a great battle, but in a cold and scared whimper. Submissive to the end of our civilization. In our conquest for knowledge and power, man will become arrogant. Claiming land and colonizing multiple worlds. One of these planets could be territory for something else. One of the greatest threats to man is the possibility of godly civilizations ending man. Something or someone that could end universes with a touch of a button and vaporize life in an instant. If you attempt to hurt them, they will end you in seconds. The possibility of an actual alien battle would be minuscule. These civilizations would be unfathomably strong. We may never reach the threshold of power and knowledge, and so aliens will initiate the attack. Weapons of mass destruction could in theory vaporize all our habitats and planets in mere seconds. But civilizations such as these would only waste this much time and energy to warn. In theory, hurling asteroids at all of man's habitats would require less time and energy, and have the same impact as huge death lasers. Man killed its mother in mere centuries. It could easily do it again on other planets, an endless cycle of death and pollution. But as time goes on, we might learn. If we never encounter these civilizations in the next million to billion years, and don't kill ourselves off, and there is a chance that we may survive, that we may learn quickly enough to prepare for these deadly attacks. We live in a perfect time in the universe, right inside the age of starlight, a perfect time for life to flourish, expand into the universe, and wonder how it all works. Mankind has proven the universe wrong before, but there's no saying we can't do it again. Maybe we will change the entire course of universal history, becoming the first godly alien civilization to ever exist, becoming the gods of the cosmic stage. For anything of this magnitude could occur, we must keep the flames of curiosity and knowledge alive. It all starts with a spark of curiosity that creates flames of intelligence, and a step forging the path to cosmic and eternal godliness.